Hello, in this video we are going to look at finding the relative or local extrema, relative or local max or mins for some functions that involve radicals or rational exponents. Alright, so our first function is f of x equals 8 plus the quantity 7 plus 3x all to the 2/3 power. So in order to find those relative extremas, we need to find our critical values, and so that means we need to find our first derivative. So the derivative of the 8 out front is going to be 0. The derivative of the second part is going to involve the chain rule. And if you need to go back and look at some videos of the chain rule, I'm going to streamline this just a little bit. So we have something to the 2/3 power. That's going to be 2/3 times our something to the negative 1/3 power. Remember, we need to subtract 1 from that exponent. And then since we didn't just have an x inside our parentheses, we need to multiply by the derivative of the parentheses, which 7 minus 3x has a derivative of 3. And so if we clean this up a little bit, 2/3 coefficient out front and the 3 from that derivative are going to simplify to just 2. And then the rest of it is raised to a negative power. So I'm going to go ahead and move that to the denominator and write this as 7 plus 3x all raised to the 1/3 in the denominator. So we get 2 over that 7 plus 3x to the 1/3. Alright, so now we need to find anywhere where this function is undefined. So undefined typically means a 0 in the denominator. So let's find out when that denominator is equal to 0. So it's going to be equal to 0 if 7 plus 3x is equal to 0. So I'm going to subtract 3x from both sides and divide by that negative 3. And we get that it's going to be undefined when x is equal to negative 7/3. And it's going to be equal to 0 when that numerator equals 0, because our first step is going to be to divide or to multiply both sides by the denominator, which is just going to give us 0 equals 2. Well, that is never true, so that means that our only critical value is going to come from that point at negative 7/3. Now we do want to make sure that negative 7/3 is part of our domain. And it is. We can plug in a negative 7/3. That's going to give us 0 in the parentheses of our original function. And 0 to the 2/3 is equal to 0, and our function's equal to 8. So we'll actually use that in just a minute. But now we need to find out whether this is a maximum or a minimum, because we don't know from the information that we found so far. We need to plug in something into our derivative on either side. So negative 7/3 is a little bit to the left of negative 2, so I'm going to go ahead and plug in a negative 3, and I like plugging in 0 if I can. So if we plug in negative 3, now we are plugging into the derivative, so we want to make sure that we're plugging into the right function. If we plug in negative 3 in there, that's going to give us 7 minus 9. So that's going to give us a negative in the denominator, because the cube root of a negative is still going to be a negative. So we get a positive over a negative, and that is going to be a negative. We're not really worried about what this exact value is, just the fact that it is negative, and that tells us that our function is going to be decreasing on that interval to the left of negative 7/3. Alright, if we do the same thing and plug in a test point that is to the right of negative 7/3, like I said, I like picking 0 anytime I can because stuff seems to simplify. We're going to get 2 over 7 to the 1/3. Well, 7 is a positive number, so the cube root of 7 is a positive number. And so 2 over a positive number is going to be a positive number, and our function is increasing. So if our graph goes down and then back up, that means the point in the middle there has to be a minimum. So we get a minimum of, we got to figure that out, at x equal negative 7/3. Remember, at is always giving you the x value, of is always giving you the y value. Now to figure out what goes in that blank, we need to plug in to our function our critical value here. So if we plug in negative 7/3, we're going to get 0 inside the parentheses, and that's going to leave us with 8. So this function has a minimum of 8 at the point negative 7/3, or at x equal negative 7/3. All right, let's do the same thing with the function f of x equals 2x plus 3x to the 2/3. So this one's going to work very similarly. Again, our domain is all real numbers there. That is defined for any value of x. So if we take the derivative of it, we're going to get derivative of 2x is 2. The derivative of 3 times x to the 2/3 is going to be 3 times 2/3 x. Then when we subtract 1, 2/3 minus 1 is going to be a negative 1/3. And cleaning that up, we're going to get 2. Those 3's are going to cancel, and we'll get 2 over x to the 1/3. This one is going to be undefined when that denominator is equal to 0, and that's going to happen when x is equal to 0. And then finding where it's equal to 0, we get 2 plus 2 over x to the 1/3. So I'm going to subtract 2 from both sides, multiply both sides by x to the 1/3, divide by negative 2, and we get that x, and then we can raise both sides to the third power. Negative 1 cubed is still negative 1. So we actually have 2 critical values here. We need to make sure when we put them on our number line, we put them in numerical order. Most negative, smallest on the left, most positive, biggest on the right. And then we need to pick something in each of those 3 intervals that we've broken our number line into. I'm going to go ahead and pick negative 2, negative 1/2, and a positive 1. Now we are plugging into our first derivative here. So f prime of negative 2, if we plug in a negative 2 there, we are going to see that this is a positive number. So that means it's increasing. If we plug in negative 1/2, could plug in negative 1/3 too. Negative 1/2, if we plug in a negative 1/2 there, that's going to end up giving us a negative number because it's going to make that denominator much smaller, making that second term much bigger. And so it is decreasing on that interval. And then f prime of 1 is going to end up giving us a 4 there. That is a positive number, so it's back to increasing. So our graph is going to go up and then down and then up. So that tells us that that 0 is going to give us a minimum, and that x equal negative 1 is going to give us a maximum. So we do see that we have a max of, we got to fill in the blank there because that's our y value. We don't know that. Our maximum occurs at negative 1. And we're going to get a relative min of, again, we don't know what that's going to be, at x equals 0. So if we plug negative 1, remember now we're finding, for our y value, we're plugging into our original function here. So if we plug in a negative 1, we are going to see that that's going to end up giving us negative 2 in the first term, and then negative 1 squared is going to be 1, and the cube root of that is also 1, times 3 is going to give us 3. So that's going to give negative 2 plus 3 is 1. So we get a max of 1 at negative 1. And if we plug in 0, both of those terms are 0. So we get a min of 0 at 0. All right, I'll see you guys next time.